evening, ladies and gentlemen. Again, welcome to the course Practitioner's Approach in Business Analytics, Descriptive, Prescriptive and Predictive Analytics. And today we are trying to get into the new topics of descriptive analytics specifically, and how do we describe the data and the importance in the in studying the decision making process or in doing the decision making. And the tool that we are going to do today is the frequency distribution and the histogram, and it is also an important tool in the descriptive statistics. So, as we said earlier, most of the time data comes in two format. Data comes in two formats, okay, unless it is a textbook, that is in real life. The format is too much or too little. Okay. So, then we have to have methods or mechanisms to deal with this. Okay. So, today what we are going to do with this, we are going to look into when the data set is large. If you have a large data set or too much of data, then what is the first step or what do we do? Okay. One of the simple way to do it is reduce data set by grouping the data to observe patterns. Okay. So, the idea here is that you group the data, and that the grouping process you will end up reducing the data set. The second thing is, by doing this, sacrifice some information to realize reduced size. Okay. So, once you have reduced the data, then you are able to, so that they can, so that easy to analyze. Okay. So, one such tool what we talk about is the frequency distribution. Okay. And what is frequency distribution? Frequency distribution, it is a table. It is a table, it is a tabular form that divides a set of data into a suitable number of classes, into a suitable number of classes, also showing the number of items belonging to each class. So, the idea here is that it is a table or it is a tableau that divides the set of data. It divides the set of data into suitable number of classes. We will talk what are the classes, but it divides into classes or groups. So, all of you are in the class of this prescriptive analytics. What does that mean? Because all of you are taking this course, so you have the similarity in that. So, classes means a group of similar items. Okay. And it also shows the number of items that belongs to that each class. That is also what is being shown. Okay. So, in a way, classes are also called as, also known as categories. Okay. And the importance of that frequency distribution sacrifices some information some information contained in the data, contained in the data, which is, what is that one? Which is implies instead of the exact value of the data, set value of each data item, we know only to which class the data belongs to. Okay. So, what happens here is it sacrifices some information. What is sacrifice? It sacrifices the exact value of each data item, and instead it is providing you which class the data belongs to. So, each individual values you do not know, but you know where it actually belongs to, or which class it belongs to, or which group it belongs to, okay, or which category it belongs to. So, why do we group into categories? Because grouping often brings out important features in the data, important features / patterns in the data. Okay. So, the main reason why we do this, why do we group? Because to bring out important features or patterns of the data is one of the reasons why we group. So, this is a tool for reducing the data set, and as I said earlier, you divide the data set into suitable number of classes and showing the number of items that belongs to each class, and classes are also known as categories. So, they are grouped by similarity of category, okay, and it sacrifices some information, it sacrifices the exact value of each data item, and instead it tells you which class the data belongs to. The reason why we do it is because by doing this we can identify the important features or patterns in the data. So, in the frequency distribution can be divided into two. Okay. The number one is the numerical, other one is the categorical. So, what is a numerical distribution? Numerical distribution is it's a frequency distribution where data are grouped according to size, or what we can call it as the numerical value. Okay. Here the data is grouped according to its size or the numerical value. What is a categorical distribution? It is again another frequency distribution. Where the data values, where the data are grouped according to some quality or attribute, So, here we are looking at some of the attribute of the data, like for example, you can divide the color, we can divide the data according to some group by the similarity of color in something, stuff like that, where here you can think about grouping in the form of numerical. So, in this class we are going to focus more on the numerical distribution. not too much on the categorical distribution. Categorical distribution is used for other aspects and it is outside the scope of this 20-hour course. So, the first step, how do we do this? Okay. The first step, the first thing that you need to decide is how many classes. Okay. So, the question here is decide, or instead of this, practitioner's challenge. Okay. One of the things that the practitioners have to do here is, okay, decide how many classes to use and choose the limits for each class. In making the frequency distribution, the practitioner how to decide how many classes to use and then also decide the limits for each class. Okay. The class limits, what does it mean? This means that from where to where each class is to go. So, the idea is this: if somebody says that young or youth is an age between 18 to 29, so then 18 to 29 is a class. The class is called youth and the class limits are 18 years of age. So, the lower limit in this case will be 18 and upper limit will be 29, like this. So, that is what the class limits are. Okay. Then what do we do? Once class limits are decided, we tally observations that fall into each class providing the class frequency which is the so what is class frequency? Which is the number of observations in each class. So, once you decide from where to where each class to go, or we decide the upper limit and lower limit of each class. So, then once these class limits are decided, once we decide it, then we tally the observations that fall into each of this class, and by doing that we get the class frequency. Class frequency means the number of the observations that fall into each class. So, obviously you have to make a decision. So, general rule, there are many rules that are available. The number of classes typically depends on the number of observations. That is rule number 1. Okay. And rule number 2, it also depends on the range of the data. Okay. Range of the data is the difference between the largest and the smallest value. Okay. So, range equal to largest data value minus smallest data value. Okay. That is what the range is all about. So, so the two things, the number of the classes depends on the number of observations, how many data values, and the range of the data values. Okay. The practitioner's rule is that, even though people say a lot of other things, the typical rule is that there is of no use, it is seldom of any use for having the number of classes less than 5 or greater than 15. So, the number of classes is typically between 5 to 15. Okay. This will help you the the best way to identify this. So, it can think about is minimum number of classes equal to 5, less than this not desirable, less than is not desirable. Okay. Similarly, maximum number of classes equal to 15, more than is not advisable. So, as a practitioner, you trying to decide the number of classes between 5 and 15. Okay. If it is less than 5, you are grouping too many things and you are losing a lot of information. If it is greater than 15, then you are not being able to identify appropriate patterns out of that. So, let us think about some more other definitions of this, okay, which are related to this. First one is called as a class boundaries, and we talked about earlier as class limits. Okay. So, we defined the class youth equal to 18 to 29 and class limits are 18 and 29. So, then what is a class boundary? Class boundaries are impossible values of class limits where no ambiguity about the membership of a data value in a class exists. So, if you think about it, let us think about it as adolescent is the age from 12 to 18, let us say that, okay, and this is one class and the youth is 18 to 29. So, the question obviously is, where would you put 18? Would it be adolescent or would you put it in the youth? So, in this case, in the class limits, this case is 12 and 18 is the class limits, here is 18 to 29 is the class limit. So, this creates a problem. So, sometimes you can make it as 11.75 to 18.25, you can say this is the adolescent and 18.25 to 29.75 is youth, let us say you put it that way. If that is the case, then you can say that these new values, these new revised values, which are impossible values for that matter, because you cannot really, the data that you collected does not have that type of values, you only have 11 years, 12 years, only the absolute value of age is what you have. Then these will ensure that 18 will fall here, it removes the ambiguity. So, these are called as class boundaries. Okay. So, class boundaries are modified class limits. Okay. When you do frequency distribution, you do change class limits into class boundaries. Then the second one is class width. What is class width? The difference between upper and lower values not of class limits, but its values of class boundaries. Okay. So, the class width of the adolescent will be equal to 18.25 minus 11.75. This will be the class width. Okay. Then class mark. What is a class mark? When a class when a class is represented by its midpoint instead of the whole class specification, it is known as class mark. So, for example, let us define a class called baby as the age from 0 to 5. Okay. So, then this is the class limits. Class boundaries, you could probably say it as 0 to 5.5, okay, as the class boundary. So, the class mark will then be the midpoint, which will be class mark equal to 5.5 plus 0 divided by 2, that is 5.5 by 2 will be that is 2.75. Okay. So, if you when you say that the 2.75 represents the class, so in your if you are drawing a diagram or something, then you can basically just use 2.75 instead of the 0 to 5.5. So, this replaces this 0 5.5 specification of the class. So, the 2.75 represents this particular class. Okay. Class overlap. What happens if the class overlaps? Okay. There are overlapping classes, but as a rule of thumb, okay, let me say rule of thumb, okay, or general rule is that it is better to design classes such that they do not overlap and accommodate all the data and all classes are of same size. This is what we call as the desirable design of classes. So, you can say that yes, you can design a class with an overlap, but it is better to design classes such that they do not overlap and it can accommodate all data, do not lose any data, and classes are of the same size. Okay. So, the size of the class, the width of the class, let it be the similar. So, you can see that the baby class is of one width, then the adolescent is of another width, and then the youth is of a different width. So, instead of doing that, it is advisable that you make all the classes of the similar width. So, what are the best way to look into solve this kind of or understand this is like, let us look into what we call as the an example problem. So, what we are doing here is we are looking at the example of lunch times. How? So, the question here is how long people take to eat lunch, okay, and people collected data and this data is given to us. Okay. Data shows the time taken to have lunch in minutes. So, this is in minutes by various employees. So, this is done in some factory and the source is Stephen Terrell's book Statistics Translated, and this example is actually taken from that book. So, here you can see that the minimum data value is 30, maximum data value is 80. You can see that this is arranged in the ascending order. Okay. Sometimes when the data is not available in the ascending order, it is advised that you sort in ascending order. So, step 1 I will say, or step 0, okay, sort data in ascending order. This is important. Okay. So, the minimum and maximum data is given to you as 80 and 50. So, which implies the range of the data is 80 minus 30, which is equal to 50. So, one is the range of the data, the frequency distribution, the number of classes depends upon the range of the data and also on the number of observations. Number of observations, how many are there? So, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 observations. So, 12 columns and this way you have 3 rows. So, 12 times 3, 36. So, 36 observations you have. Okay. So, these two things, okay, the choice, now the question here is, your practitioner's choice is how many classes to make, and second is what are the limits, and then class boundaries. Okay. So, you do class boundaries so that ambiguity, the limits gets translated to the class boundary so that ambiguity is removed. Okay. And the rule of thumb that we said is 5 to 15. Okay. There is another rule. Okay. Another rule is the square root of number of observations. Okay. This is not very popular, only used in the case of small data sets. So, we will not follow this, but some people do use the square root of the observations to decide the number of classes. If this is more than 5 and 15, then you round it to 15. If it is less than 5, then you round up to 5. That is the way people do this. But this is not a very popular rule, but I am still mentioning that this rule is available. Okay. So, the first thing we need to do is, okay, so since we know that the number of classes, so the range was found out to be 50, and so if number of classes is equal to 10, then class width will be 50 by 10 equal to 5 equal width. So, you would have 10 classes of the equal width. So, if you think about it, so then the minimum value starts is the minimum is 30, maximum is 80. So, your classes will be 30 to 35, 35 to 40, 40 to 45, 45 to 50, 50 to 55, 55 to 60, 60 to 65, 65 to 70, then 70 to 75, 75 to 80. So, you will have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 classes. But obviously, when you do this and if you look at the data values, you will see that where will you put 40? Let us take the data value of 40. Will the data value of 40 go here or will go here? So, now we can see that the class limits need to be revised to eliminate the ambiguity. The ambiguity of where the 40 belongs to or where 45 belongs to, like that. So, to do that, there is one way is that since we have taken the number of classes as 10 for easy division and other things, one way to do it is I can always or we can always say that let us modify the range. Okay. The range now starts from 28 to 81, giving result to 53 as the range. So, that is given by 81 minus 28, 53. Number of classes equal to 50 is equal to 10, which implies class width equals 53 by 10 equal to 5.3. So, since you have a decimal point and all your data values, every data value here is an absolute value without any decimal point, by using this decimal point you can ensure you can eliminate this ambiguity. Okay. So, now with this you can have a new classes. So, now our next step is to create the frequency distribution. So, I am going to do it like this. I will say it as classes, then the classes will be, I will start at 28.0 and I will move to, if you add 5.3 to this, it will become 33.3. Then the next one will be 33.3, it will move to 38.6. Then from 38.6, it will move to 43.9. Then 43.9, it will go to 49.2. Then 49.2, if you add 5.3 with it, you will actually get it as 54.5. 54.5, if you add 5.3 with it, you will get 59.8. Then 59.8, you add 5.3, you get 65.1. And 65.1, you add 5.3, you get 70.4. And 70.4, you add 5.3, you get 75.7, and 75.7 you add 5.3, you get 81.0. So, this is the classes that you have. Okay. Now, one way to do the frequency distribution, the simplest way to do the frequency distribution is you do what we call as the tally markers. Okay. So, what we do is you go back to the data and see between the range of 28 to 33.3 how many data values are there. So, if we go back and we check, we have 30 is there. Okay. That is only one data point that we have. So, then we come here and we say tally of 1. From 33.33 to 38.6, how many data values are there? So, that is 35, 235s are there, 40 is outside the range. There is no ambiguity in that. So, we basically say 2. Then 38.6 to 43.9, if we go back, we will have 1, 2, 3, 3 40s between that value. So, we go here and write 1, 2, 3. Then 43.9 to 49.2. So, between that only 45s will come 1, 2, 3, 4, 4 of them. So, then we basically do 1, 2, 3, 4. Then 49.2 to 54.5, go back and say that will only you get is 50, 1, 2, 3, 4, 5, 5 50s. Okay. So, we will go is, it will be 1, 2, 3, 4, 5. Then 54.5 to 59.8. So, that will be, if you go back, you will actually get only 55. So, 1, 2, 3, 4, 5, 6, 6 55s are there, and 60 will not come because it is outside that. So, we go back. So, that is the 6, 1, 2, 3, 4, 5 and 6. Then 59.8 to 65.1. So, 59.8, 65.1. Okay. So, we are going there. So, 59.8 and 65.1 means both 60 and 65 will come in. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 of them. So, then we go back and do the tally 1, 2, 3, 4, 5, 1, 2, 3, 4, that is 9 of them. Similarly, if you look at this, you have 3 of these, then you have 2 of these and 1 of these. So, this tally is what we just call as, and then you write that. So, here this tally tells how many observations or data belong to the class. Okay. So, then the next one we can create out of this is called as the frequency. Okay. So, the frequency is more like counting these numbers 1, this is 2, this is 3, then you have 4, then you have 5, you have 6, then you have 9, then you have 3, then you have 2, and then you have 1. Okay. So, this is your frequency. So, if you sum all the frequency, okay. So, if you say that sum total of all frequencies, okay, if you do that, that is equal to 1 plus 2 plus all the way up to 3 plus 2 plus 1, do that, that gives you how many observations? It gives you a total of 36 observations of this. Okay. So, this is the sum 36. So, this 36 observations 3 plus 2 5, 5 plus 1 6, 6 plus 9 15, 20, 26, 30, 33, 35, 36. So, 36 observations you get. So, all the observations are put it into each one of the class marks. So, now if you look at this, you can see that the individual observations, we lost the individual values, these are no longer there. Instead, what we have is which class or how many of them will belong to each class is what we have. Okay. So, one another thing that we can do out of this is quickly that can be done out of this is the second step is finding the class marks. Okay. So, now let us see finding the class marks. So, what is the class marks? How do we find it? It is the midpoint of the class. Okay. In our case, you can see that all classes are of equal width, okay, and all the data points, okay, here all 36 data values are captured. Okay. So, in that regard we can say that we have basically fulfilled the rule of thumb that we predicted, which basically says classes should be of equal width and classes should not have any ambiguity and all the values should be captured. So, if you think about it, this is a good frequency distribution that is being built. Now, if we look into this, as I said, finding the class marks is the midpoint of the classes. So, let us draw the table a little bit more nicely. Okay, this time we won't do the tally and other stuff. So, we will say class width, okay, or not of class width, classes, then we have our class marks, then we have is our frequency. Okay, let us do so far. So, the classes were once again 28.0 to 33.3, 33.3 to 38.6, or we were adding 5.3 which is the class marks, then 38.6 to 43.9, 43.9 to 49.2 and 49.2 to 54.5, 54.5 to 59.8 and 59.8 to 65.1 and 65.1 to 70.4, 70.4 to 75.7 and 75.7 to 80.1. Okay. And the class mark ideally is the midpoint. Class mark is the midpoint. So, the first class mark will be 33.3 plus 28.0 divided by 2, which should ideally give you the number of 30.65. Okay. So, the class mark here is 30.65. So, when you say 30.65, that literally means it represents the class 28 point. So, it represents this class. Similarly, the other one is 38.6 plus 33.3, which will give you 35.95, and similarly 43.9 and 38.6. If you find the midpoint of it, it will be 41.25. Similarly, 49.2 and 43.9, if you do this, you will get 46.55. Then it is 51.85, 57.15, 62.45, then 67.75, 73.05 and 78.35. Okay, and the frequency of this is, as I said earlier, 1, 2, 3, 4, 5, 6, 9, then we have 3, 2 and 1. Okay. So, this is the frequency, and the sum of the frequency was studied up to 36. Then the next concept that is applicable in part of this is what we call as the relative frequency. Okay. So, the relative frequency is calculated, I will be writing here. The relative frequency equation is equal to, so if we call this as f sub I, individual frequency, fi divided by n, and this is your n. Okay. So, the first relative frequency will be 1 divided by 36, okay. That will come to 0.028. The next will be 2 by 36, okay. So, that will give you 0.056. Then the third one, 3 by 36, will give you 0.083. Then the fourth one will give you 0.11. Then you will get is 0.14, then 0.17, 0.25, 0.083, then you have is 0.056, then 0.028. Okay. So, these are the relative percentages. In a way, think about this, this actually tells you that this class, the 62.45 class mark or the 59.8 to 65.1 contains 25% of the data values in this. So, the relative frequency kind of tells you, the relative frequency provides information on what percentage of the observations fall into that class. Okay. So, that information is made available to us with the help of relative frequency. So, now with this data, one of the ways to think about it is, okay, you did it. So, what did it actually help? So, if you want to find out in this particular time where will be the maximum number of time people will be taking lunch, if you want to find out of this time period, this particular time period, I know it is not kind of straightforward to read. So, I will kind of do this so that you can understand. Sorry, my writing is not very in that particular order. So, you know what values we are talking about. So, you can see that this particular case, okay, let me put it this way, kind of wrote in a different goofy fashion. So, you will understand what I am trying to do. Okay. So, in this case you can see that about 25% of the people, okay, one thing is 25% of employees take 59.8 to 65.1 minutes for lunch. So, it is 1/4 of the total crew actually takes somewhere close to 60, between 15, about 1 hour for the lunch. Okay. There are people who finish the lunch early also, but it is a very small number. And one other way to look at it is you can start cumulating these frequencies also, but we are not going to work on that. You can do that, you can do many more fancy things with this stuff. So, that allows you lose exactly what was the lunch times of individual people in this. You do not know that, but you get this new vital information that yes, 1/4 of the total crew wants this, take lunch in that. Then you also know that 17% of them take the lunch between 54.5 to 59.8 time period, and then 14% of them takes typically between 49.2 and 54.5. Though you don't know the exact values of it, but you kind of know. So you can see that this much time period, if you look into this, you have this, which is 0.25, you have 0.25, then you have 0.17, 0.14, 0.11. If you think about this, that is 4, 5, 17, 1, 2 plus 3, 4, 5, 6, 6. Okay. So about 67, this is 0.67. So about you can say that 67% of the people take lunch between. One other way to think about it is 67% of the people, 67% of employees have lunch within 43.9 to 65.1 minutes. Okay. So this is an important information. The majority of your people, this is how much time they will take to have lunch. So that information is of vital importance to us in this regard. Okay. Now, obviously, the question that we have to ask is, why is this an important thing? The important thing is, once you have this frequency distribution created, then the easiest way to do it is, this frequency distribution can be best displayed with the help of a graph, and the most common graph is what we call as a histogram. And what is a histogram? Histogram is a usage of bar or rectangular bars to demonstrate patterns in the frequency distribution. Okay. Many of the software, Excel and other things will do this for you. So what we will try to do is, we will try to plot a histogram here. Okay. So there are multiple ways you can plot. Here is your x-axis, here is your y-axis. Okay. And x, we will say it as the class marks for the time being. Okay. Can use the class width also, but this is where it is easy for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have your 10 classes. So I will say it as 30.65. This will be 35.95. This will be 41.25, 46.55. Then you have is 51.85. Then is 57.15 and 62.45, then 67.75, then 73.05 and 78.35. So these are the class marks of the 10 classes you have, and you can say, let's put the counts here. So we will say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, stuff like this. So for the first class we had a frequency of 1, and then the second class the frequency was 2, then the third class the frequency was 3. Okay, I am trying to draw this properly, but you will understand, 3. Then the next one is 4. Okay. So we draw it as a 4. Then we had is 5. Okay. Apologies for the ugly drawing. 5. Then we had is 6. Okay. Then we had is 9. So it's like kind of right here. Okay. When you draw, actually you draw with a software or something. Then we have is a 3, so somewhere here. Then you have is a 2, somewhere here. Then you have is a 1, somewhere here. So if you look at it, this kind of a graph. So here is where the number of observations, or what you can call it as frequency. Okay. So, you can kind of see that there is kind of a, some people will probably say this kind of shows a bell shaped curve kind of a thing, or the data tend to show normal distribution or something like that. You can also say that you can also, if this number of classes, if you reduce the number of classes to, let us say, if number of classes is reduced, okay, then it implies that the shape or pattern may change. Okay. So, one of the things as the practitioners do, practitioner should vary class marks or number of classes to see changes in data patterns. Okay. This is something that the practitioner is expected to do, because by doing this the practitioner will be able to find which is the best number of classes available for this. Okay. So, with this today we complete our lecture, and I hope that you guys understand the concept of histograms and as well as the frequency distribution, and how frequency distribution can be used, histogram can be used to pictorially depict the frequency distribution. And I advise you guys to use Microsoft Excel to do this, because Excel has a very good graphing tools, and R can also do this for you, but it is very easy to do this in Excel. And hope that you guys learned something out of it, and see you guys in the next class. Thank you.